Next up, we're going to have a lecture by Mike Santangelo entitled Means to an End.
Hello, everyone. I want to talk about the means to the end. How do we implement the resource-based economy? I'm going to talk about it from the technological standpoint. Much of this technology already exists today, and some of it is still sort of in the development stages, but is definitely feasible. And of course, none of this would be used for weapons or military or destruction, but for actually benefiting humankind. The technology I'm going to talk about can be seen in the Zeitgeist films and also in a short film entitled Our Technical Reality, all of which are available on YouTube. First, I want to talk about energy. Green, renewable, abundant energy. Now, we're all familiar with solar energy. It's been around a long time. You've seen footage or pictures of the solar panels in open fields. But there's new technology around now that can really maximize this potential better than those. The solar cells that you see in open fields are limited by cloud cover, atmospheric, weather changes, the daily rotation of the Earth. How do we overcome this? There's something called a power sat. A power sat places the solar cells in geosynchronous orbit around the Earth, so it can collect the energy 24/7. The energy is then beamed down to the Earth wirelessly for use by people. Birds and airplanes can fly through the beam with no ill effects. There are also spherical solar cells made of silicone that can be put on orb devices or even in window panes on the glass. They can generate more power than traditional solar cells because they absorb light from all possible angles. There's also something called geothermal power. The inner core of the Earth is very hot, reaching thousands of degrees Fahrenheit. This heat must escape from the Earth. It journeys up and comes out in natural vents, usually along plate lines. Tapping this using heat mining can actually use that rising energy to generate power. It is completely abundant, completely renewable. It can release some greenhouse gases from these vents, but at a far lower rate than burning fossil fuels, and therefore is sustainable. Energy can also be generated by the temperature differences in the ocean. There's something called ocean thermal energy conversion, OTEC, which uses a process of evaporating and condensing to get energy from this temperature differential. Also, ammonia can be used in some of the chambers so that the electricity can be generated at very low temperatures. Then there's wave power. This can be harnessed in a number of different ways. I will talk about two of them. You can place cylindrical devices in the ocean that are connected by hinges. They float on the surface, and all this constant wave motion that happens 24/7 moves these and can be used to generate power. Also, you can put a power station at the edge of the water, right by the beach. The water can then flow up and back as the waves go 24/7. Inside is a vacuum, and when the water comes up or comes down, it forces air through this channel. Special technology has been used to create a two-way turbine in here that will spin in the same direction no matter which direction the air is flowing. Even at a time when the ocean is relatively calm and there are a few waves, you can still generate a lot of power with this method. I also want to talk about wind power. We've all seen the traditional wind turbines in fields. This has been criticized as too weak, but there is new technology that can make this better. For example, you have a wind turbine system with flaps that can collect more of the air and spin the device around to where the air is coming. The turbine inside is suspended on a magnetic field. This causes there to be almost no friction, allowing the turbine to spin much faster than with conventional methods. You can get 500 times the power than you can with a standard wind turbine. This also requires a lot less land area to do the same job. So you can stack many of these and generate far more energy than we have been in the past. There's also something called a Bloom energy fuel cell. This is a small cartridge approximately this size and this thick, which has natural gas and oxygen inside. These produce a chemical reaction which can be used to generate power. These cells can be stacked and clustered and boxed. If you take one roughly the size of a parking space, you can power an entire Starbucks coffee shop. Just like with data, as your computing needs increase, you stack and cluster your servers. Same concept with these cells. Just put clusters of them, stacks of them. The more power you need, the more you add. Now, some people have touched on agriculture tonight. I want to just talk a little bit about that. We can now grow plants indoors, regardless of the weather, with no soil, and only 1% of the water needed in conventional agriculture. The plants can be stacked in stacked up rotating cylinders. Now, when a plant is growing horizontally, in a few minutes' time, it will bend up towards the light source. This is called a phototropism. And these stacked up rotating cylinders can rotate around the light source and exploit this tropism that the plant does. This can result in crops growing faster, bigger, with more nutrients and more abundance. Then there's transportation technology. Today we use mostly hydrocarbon vehicles that produce a lot of emissions, and there are traffic accidents because of human error. This can be changed. There's something called ULTRA, the Urban Light Transit System. It's fully automated, fully electric. You can get to your destination faster than you can in a conventional car, with no parking hassles and no wait times. These vehicles run on precisely run intervals. You can meet your vehicle at any point. They can usually take you to the front door of exactly where you're going. This system has already been instituted in London's Heathrow Airport and is operating today. One thing that can be developed, and this is a good example of technology that exists but does need more development, artificial intelligence in transportation. We can now build cars that can drive themselves. No one needs to be steering it from remote control. And again, this is sort of in its infancy, but the potential will be realized. There will be less traffic accidents because machines do not make mistakes. People make mistakes. With these type of cars, people who are visually impaired can get to their destination simply by saying, "Take me there." If you're sleepy or if you've been intoxicated and you're not in condition to drive, you can have this thing take you home safely.
What about insurance companies?
You have to ask the Allstate guy. He's speaking next. Another piece of technology is once again using the magnetic field that I talked about earlier with wind power, maglev trains. These are trains that ride on a cushion of a magnetic field. This greatly reduces the friction and can allow the train to pass much quicker. These trains are already in existence and can go hundreds of miles per hour. But again, as another example of something in its infancy, there are plans to build tube-based maglev trains that can travel over ground, underwater, and reach speeds of up to 4,000 miles per hour. They can even withstand the impact of a sonic boom as the train reaches the speed of sound. Then there's medical technology, medical robotics. We already have bionic limbs. We can fix them. We have the technology. So if you ever notice, a lot of times people that are amputees, if they have an artificial limb, their gait and their walk is affected. It's sort of awkward. Sometimes they have to make special accommodations to get upstairs. Well, now we have motorized robotic limbs that have artificial intelligence built into them. For example, if someone has their leg amputated at the knee, you can wear this device from the knee below, and the other leg, the good leg, will have a band around it and a sensor in the shoe. This collects the data of what the good leg is doing and actually teaches the robotic leg to do the same motion. And these people can walk and do tasks that had been previously too difficult for them, and they can do it less awkwardly and more normally. Then there's robotic surgery. Now at this point, surgery is not completely automated. Doctors are controlling by levers these robotic arms. The potential here is amazing. We can already do a lot of surgeries with this method. For example, if you need to operate on someone's lung, presently you have to make a big incision all the way down here and open up their entire sternum. This is extremely traumatic for the human body. It causes a lot of pain, long recovery times, you name it. With these type of incisions, we can actually go through the mouth to do this surgery. Surgeries will be less invasive, less painful, we'll have faster recovery times, better success rates, shorter hospital stays, and someday this will be automated. Surgeries will be performed by machines, much better than people can do it. The last thing I'd like to talk about is 3D printing. We're all familiar with two-dimensional printing. You type your Word document, you send it to the printer, it comes out, and you can read it. Well, there are printers now that can produce three-dimensional objects. There's something called Objet, a company that has used CAD, or computer-aided drafting. This is technical drawing by computer. You can design your structure or your object, and then the printer will print it out in layers with a plastic-like material going up like this until the object is produced. They can even print things that have moving parts. There's something called 3D concrete printing, which has the potential to revolutionize architecture and engineering. You can use the computer-aided drafting to create very intricate concrete designs that are not buildable with the traditional concrete mold, and the printer can print these. You can make the structures prefabricated and then assemble them into a building. And I also wanted to add that there are 3D printers now that can replicate themselves. You give them the materials and the information, they can construct another 3D printer. So when people tell you that the resource-based economy is a pipe dream and that this technology can never be implemented, tell them about that and show them the video, Our Technical Reality. Thank you.